It's a beautiful Thursday morning to be in Melbourne. Amazing. The weather is perfect. And a lot of us also get hay fever as well, thanks to the weather we live in. And before I get started, I would like to thank Cam and his team as well for organizing this event year on year, both in Melbourne and Sydney. I've been wanting to attend this in person. If I wasn't here, I wouldn't know how tall Cam is. I've just seen him on video calls previously. But to do that, I was speaking to Jackie, who is one of our QE directors, and she said, yes, you can attend testing talks, but you'll have to present. That is the only ask. And here I am presenting in front of you all, talking about how to leverage your existing automation test suite for performance testing, which is what we have done for one of our clients. I'll get started with a brief round of introductions. I've tried to do it with 5 pictures about me that describe me well. I was born and raised in India, not really close to Taj Mahal, but somewhere in the northern parts of India. I moved to Melbourne. So yesterday afternoon, I was thinking, when did I actually move to Australia? And that was exactly 14 years ago. In the same month, but I landed on Halloween's Day. So it was amazing to see people in the city all dressed up as zombies. And it was a bit of a cultural shock. But since then, Melbourne has become my home, and I love it here. I have a beautiful 9-year-old teenager and a 40-year-old child. I love them both dearly. We love celebrating Indian festivals together, and this is one of the pictures from a Holi celebration we had in our community earlier this year. I work at Deloitte. I've been with Deloitte for almost 8 years. Yes, that's a long time for me to have been working with an organization for that long, but it doesn't feel like 8 years because we keep getting new challenges every couple of months, couple of years, learning something new, and we also like to reinvent ourselves. So we were part of, I don't know, I keep forgetting the names. I'm losing track of what we were called earlier, but now we are part of AI engineering and data team. And quality engineering is part of that, and Deloitte does do testing. We hear a lot about, oh, isn't that an audit firm? Isn't that just do consulting? No, but we also do performance testing. We also do quality engineering. We also do automation as well. I've been in the IT industry for over 18 years now. Yeah, I do feel really old. Some might think 18 isn't a long time, but IT ages you. It ages you really quickly. I started my career in performance testing and mostly been doing performance testing. However, lately I moved into, when I say lately, almost 5-6 years ago, I moved into delivery and program management as well. So I don't do just performance testing, but also do test management and manage large pieces of programs too. The picture at the bottom, that just shows about what I really like to do. First, I thought I like to travel, but getting old, I've realized I don't like to travel as much, but I do enjoy sitting on a beach, reading a book, and sipping on pina colada. I love that. When I don't get that opportunity, I also have another oldies interest, which is gardening. So I definitely don't look as pretty as the young lady there while I'm doing the hedges around the house. But last weekend, that's exactly what I was doing, trimming the hedges, not so elegantly dressed with the pink gloves and all, but I love doing that. So in case anyone wants to connect afterwards, asking questions about performance testing as well as gardening, how to grow an avocado tree from a pit, you know where to find me. I'm more than happy to field any questions around that. Before we get into it keeps moving on its own. Before we get into how we can leverage automation scenarios or automation scripts for performance testing, let's talk some facts. This is a very wordy slide. I wouldn't go through all of them, but it just is trying to give you an idea of how important and how critical performance is. Especially we are living in the age of selfies, quick YouTube videos, shorts, reels. We don't have that much patience. We can't watch 10-minute videos. Forget about online shopping where your website just takes forever to load. We want everything quick. To do that, the websites need to meet the performance needs as well so that they can keep users engaged. So some of the facts. A 1-second site loading speed delay might decrease conversion by 7%. A study found that 2-second delay in load times increases the shopping cart abandonment rate by 87%. That's a lot. That also tells us something about how we all are, how impatient we all are. But to meet the needs of the market, websites have to keep up. They have to invest more time and effort into ensuring that the systems and the applications we are building are user-friendly, are fast, and are engaging. We need to invest in performance to ensure that. Some of the other examples. I don't know how many of you guys remember the Oscars 2014 selfie that broke the internet from Ellen. This selfie was shared more than 2 million times in a day, and it almost broke Twitter. There might be a few Swifties in the room who might have tried, Swifties in the room, or their kids might be Swifties, who would have tried to book Eras tour tickets, and the website crashed. You always remember when the website crashes. You might not remember when the website is working properly. Prime Day, 2018 Prime Day crash cost Amazon approximately $72.4 million of lost sales. And a lot of other images on the left that show you how amazing our government websites work. Some of them, ATO lodgement, website crashes due to high traffic volume. Some of you might remember the census website from a couple of years ago where everyone tried to submit their forms, and what happened? This is why we need to invest in performance. What is performance engineering? How many in the room actually work in performance testing, have worked in performance testing work? Perfect. A few, but I'm glad to see you all here. What is performance engineering? It is a holistic approach to ensure software reliability and efficiency. Reliability, as in you saw the example earlier, how reliable are our websites? If we are trying to think of gaming websites as well, so Melbourne Cup Day is coming. The gaming websites get more than 90% of their revenue from just one single day. Imagine the website crashing only for a couple of minutes at that time. What would be the impact? It's a huge financial as well as impact to their visibility and how people perceive them. We just talked about reliability and efficiency, scalability as well. When the user volumes increase, who would have thought in 2014 that a selfie could be shared 2 million times in a day? Nobody did. Now it's a common thing. However, it caused a website like Twitter, now called as X, to crash as well. So you need to ensure that your application is scalable as well. Again, that's where performance testing comes into picture. Some of the tools available in the market, didn't want to spend a lot of effort going through the tools. However, just to give you a brief idea of what's available. Some of them are really old. When I started my career with LoadRunner when it was called Mercury LoadRunner. Now it's called OpenText. I also remember having a server room just for myself where I had 40 different CPUs where I was RDPing into them and installing LoadRunner agents to run my test on. things have changed since then. A couple of years ago, I did testing of the AO website, where one of the scenario was within the first 10 minutes, the traffic goes from 0 to 1.2 million users. You can't do that with the old tools. I could do it because I could spin up load generators in the cloud at that time. There are multiple tools. Some of the tools are open source tools, but they're also off-the-shelf products like LoadRunner available in the market. I'll go and I'll give you a brief about Gatling, because that's the tool we used for the scenario I'm going to demo on. Gatling is a load testing tool for web applications designed for DevOps and continuous integration. In all the testing talks, even the ones you have heard earlier, CI/CD, testing early, shift left, that is the theme, implementing AI. Because we want our products in the market much quicker than it used to be earlier. You are not going to wait 2 to 3 years for a single go live. You need everything fast and efficient and reliable. And you need to build your tools into CI/CD pipelines so that you're able to quickly find out performance issues rather than having to wait for the last cycle, which is usually the non-functional testing cycle before go live. Usually done a month or 2 before go live, and you're still testing a week before go live, finding critical issues. I've been there. And then we look as the bad people in the room who are preventing the go live from happening. And performance issues are not easy to fix. They require significant architectural changes as well. The reason we used Gatling for our scenario, because it is a tool that our developers can also easily understand. Jackie likes to say all the time, quality is not just testers' responsibility, it's a shared responsibility. We are just the gatekeepers of it. So when we build performance scenarios, we want to ensure that even our developers can run them. That's why we chose the tool we chose at that time. Some basic comparison around some of the open source tools I have used. JMeter, anyone who is in testing world would have used JMeter as well. LoadRunner, JMeter, they are the 2 most common tools available. Both of them were assessed for the scenario we wanted to test. However, JMeter, although it's more user-friendly, has more community support available, it is bulky. It does need a lot of load generators to support the volume of traffic we wanted to test with. So anyone in performance industry knows performance testing isn't cheap. It comes with a big price tag, especially because you need skilled resources. You also need a lot of infrastructure to support it. When you want to simulate 2 million user load, you can't just do that with 1 or 2 laptops, or you can't just do it with 1 EC2 instance. You have to spin up big infrastructure to support it. That's why you want to use a light source tool as well, so that the infrastructure overhead to run your load generators isn't massive. And Gatling fitted our use case perfectly at that time. Another term all of you have been hearing is about shift left testing. I briefly touched on why it is important. If we wait until a month before go live, try and find performance issues, we'll just be waiting. We wouldn't be going live the next month. That is what the traditional approach used to be. It still has its place. We still can't eliminate having a dedicated performance testing window close to go live. But you can't just wait until the very end to do it. You need to shift it to the left. You need to build quality into your pipelines. You need to build quality in your build. That's where shift left practices come into picture. Early performance validations through developer baseline and unit performance test. So not just testing end-to-end scenarios, you want to unit performance test your APIs as well, as an example. You want to have that shared responsibility where developers pick up some of the ownership of ensuring the application they're building, the components they're building, meets your performance needs as well. And some of the emerging trends around, we have heard about AI-generated. A lot of AI investments are happening within organizations. We heard Ravi speak about it earlier as well, and he briefly touched on how they could use artillery plugged into Playwright so that they could reuse their automation scenarios for performance testing. My use case is slightly different. I'll come to that quite soon. So coming to the topic of unlocking performance with your automation test suite, I'll come to the use cases which are covered in the next slide. API performance from your functional tests, converting existing API test cases, API automation test cases to use for performance test scenario. Normally what happens is performance testers get onboarded once we are almost in the middle of SIT cycle or is almost over. Then they spend a couple of weeks trying to understand what the system actually does, speaks to lots of testers, speaks to business BAs to get a view of what's really involved, what are the critical scenarios we want to test, and how to simulate that. And almost half of the effort is spent in writing the automation scripts for performance testing, because you can't run 2 million or 5 million users just manually. You need automation scripts for those. A lot of effort spent there. And at the back, the delivery lead is screaming, why is it taking so long for you to even getting started? You haven't started seeing any value delivered because you haven't executed even a single test case. To minimize some of that, we came up with the concept. It's not a new concept. A lot of people would have done that as well. We came up with the idea of why don't we use what's already existing from our API automation scripts? Why don't we just reuse them for performance testing as well? It gave us a lot of benefits as well. I'll come to the benefits, and I'll go through the use case we had. So we had Karate framework available with us for the API scripts, and one of our scenario was there was a client portal dashboard end-to-end transaction. If you think of dashboard, for example, a member portal dashboard, it would be making a lot of API calls related to find me all the transactions I have completed in the last 5 years. Show me my investment summary as an example. Show me my beneficiaries. All of those are API calls in the backend. And we wanted to simulate that without having to write our own performance test scripts. We were able to test around 20K plus total users per hour just via one virtual machine. If I had used JMeter, I would at least need to invest in 10 to 15 JMeter VMs. But using Gatling, it saved us a lot of cost by not having to spin up new instances. And it's not just about getting more servers, it's also that you need to maintain those servers as well. So it gave us the benefit of not having to spin up new and not having to maintain multiple sets of load generators too. The other use case was around component-led load test cases. So before you go into end-to-end dashboard-specific testing here, we also had scenarios we wanted to test our specific microservices. To do that and to build them into our system test pipelines, we were able to use our automation scripts that were available to us. Yes, you can't use all your automation scripts. You still have to spend effort in identifying which one are the right fit for your test scenario. Again, similar thing. We use the same Gatling Karate automation scripts available, and we pulled them into a Gatling framework. I'll go through a demo because how demos usually go, I don't trust technology. So what I've tried to do is I've tried to record my demo, and I'll quickly present it here, hopefully. Comes, yeah. Sorry, give me a second. And this demo is about, this is not the actual client's scripts, but to give you an idea of how you can use your Karate API scripts. These are very basic ones, how you can reuse them, call them in your Karate Gatling test workload. So when you're doing performance testing, you not just write the scripts, you also write your test scenario. A test scenario could be, is it a load test you're running? Is it a soak test? Is it a break test you're running? Depending on scenario, you want to test how much load can application hold. So you need to not just set up scripts, but also the workload. Here, you just have to do the workload, and you're able to reuse the scripts. So I'll quickly go through that.
Member portal transactions reused for performance testing. It includes 7 API automation scripts for a user registration, login, update user details, and some basic administrator functions. First one. As a member, I would like to update my personal details like name, job title. Second, as a new member, I would like to register, and for that I would enter my email ID and password. Third, as a member, I would like to log in using my email ID and password I registered with earlier. Fourth, create a new user and log in successfully. Fifth, as an administration of the portal, I would like to see the details of a single user. Sixth, I would like to see details of all users. Seventh, I am a leaving member and would delete my personal details from the portal. These API automation scripts are executed as part of nightly regression test pipelines. Now I want to plan performance testing for the portal application, and most of the business user load is via these critical transactions as well. Usually we would write separate performance test scripts using tools like JMeter or LoadRunner, or in this scenario, it is done by calling these pre-existing automation scripts in a Gatling test scenarios. This saves us the effort of writing and maintaining separate performance test scripts. The Gatling test scenario includes all 7 API Karate features we viewed earlier. This is done by including the location of the scripts in the test scenario. Performance transaction names, post-transaction, post-login, etc., defined for all key transactions. All values are parameterized to allow updating at runtime, as you would normally define in a load test scenario. Parameters to number of repeats per iteration for each transaction. Total number of users to run the load test with. Ramp-up duration for each transaction, set to 60 seconds here. Total number of users per transaction set to 3. Total steady-state execution time set to 5 minutes. The benefits of this approach are: 1. No scripting work required for performance testing, as we have reused automation scripts. This saves time and cost. 2. Every time the API scripts are updated due to code change, Gatling Karate framework calls the updated automation test script. We save time and effort by not having to maintain the changes at 2 separate places. 3. These scripts are easily loaded in the CI/CD and are executed each night, with each new deployment and on demand. The test setup in a standard performance test scenario setup, you would normally include the performance test use case you're trying to achieve. The setup is calling existing automation scripts that are maintained by automation test team. As you can see on the screen, the test was compiled and executed with 3 active users. You can also see the elapsed time on the right and the status as OK for the total transactions that have been executed so far. The Gatling execution shows the standard performance metrics, response time average, maximum, minute, various percentile values on the screen. It creates a HTML report at the end of the test. When the automation scripts get updated due to code change, as an example, here the login script is updated by automation tester. Those changes are readily available to the performance tester, hence saving the maintenance effort. At the end of the test runs, Gatling report is available that shows response times for each API, passed and failed transactions, detailed report for each transaction in test scope. These reports can be used to compare the performance degradations due to code changes. This demo doesn't use client data but shows the approach that was followed to reuse existing automation framework where available. This approach is well suited for API-based scenarios and based on the requirements, A mix of reuse and dedicated performance test scripts might be required. Thank you.
Thanks for that one. I tried to make my life easier by not having to demo it here and pre-recorded it and used a better voice than mine. So it looked pretty simple there when we went through the use case, but it's not always that simple to implement. There are always going to be challenges, especially in reusing that approach. Before we were able to successfully implement it for this client, we tried to implement it on another client, but that was more TCP-based transactions. The automation scripts weren't written in a framework that we could easily import for performance testing. So we still ended up doing separate performance test scripts. But in this case, we were able to utilize some of them. Normal challenges you would face is your automation scripts are not written to test performance. They're usually written to, for example, to test a particular button on the screen, to get a specific kind of response, to test are you getting a 200 response back or not. So it's quite different. So choosing the right scripts that you can reuse, which are also critical to the business, is your first starting point. So that is where your most time will be spent on in planning. When we got success with this, reusing our API automation scripts, we got really excited. We're like, why not just reuse our UI automation scripts as well for performance testing? And that would give us client-side performance data as well. We did not win there. We failed miserably. Where you noticed earlier that with my API scripts, we were able to use just one VM to simulate 20,000 plus transactions an hour. It was more than 20,000 transactions. It was 20,000 users simulation in an hour. When we tried to use our Selenium automation scripts, I couldn't even get to less than 10% of that load and I tried to use around 30 VMs at that time. So that's where your downside is. Why I couldn't do that is because your UI-based automation scripts, they interact with the browser DOM. They render the UI and execute JavaScripts, which introduces significant overhead as well. So some might have success with that, but I would say test your use case thoroughly before you try and reuse your UI-based automation scripts. You might be able to get some, if you're keen to test your client-side performance, then what you can also do is instead of reusing all your automation scripts to run as part of your performance pipelines, maybe just run your UI automation while your performance test load is going on. So you test the server-side performance using the APIs, but you run just one or two user through your UI automation scripts in parallel to that. That would give you some indication of how the client is performing when the server is under load. Data limitations. Your automation scripts might not need a varied amount of data. They might not need the volume of data you would need for performance. Again, taking the example of that dashboard scenario we went through earlier. The performance of the dashboard will vary significantly depending on how much data that member has. If a member has 10 years worth of transactional history, also had multiple investment options, if you try and load the dashboard for that member, it will take much longer than loading a dashboard of a member who just recently joined. So you need to consider that as well. So you would need to, when you try and reuse the API automation scripts, you need to reconsider, are those scripts considering your data needs as well? Do they have that varied amount of data, or you want to modify that? These were some of the challenges we faced. Tried, the approach was really helpful because I'll come to that, integrating your performance testing into CI/CD. We already had automation pipelines running every night. if we wanted to maintain a separate set of performance test scripts, and considering we live in agile world, the code changes with every release. The code changes every sprint. There is a release every quarter. Trying and maintaining two sets of scripts is costly, and it requires resources. We could reuse that was readily available through automation scripts, and because automation scripts were getting updated with every release anyways, we were able to just reuse them, plug them into our CI/CD pipelines, and run them every single day. It gives you the option to plug in your performance testing in every stage. You might want to tweak your volume of data, volumes that you're testing. So if it's a dev environment where you usually won't have the same size of infrastructure as your performance test environment, it might be 10% of your production. You just want to reduce the volumes to that level. You might just want to run a 10-minute test every night just to see if the performance has degraded from yesterday versus today. So depending on which stage or cycle you are in testing, you can simply make changes through your runtime parameters and test performance using your existing scripts. Lastly, some of the key takeaways. Think of the tooling you want to use. Try and use tool that has lesser overhead, that can seamlessly plug into your performance testing scenarios as well, which is what we did here using Gatling. Asset reuse. So this whole discussion was about asset reuse, not having to maintain your separate performance test scripts while trying to reuse your automation. So that gives you a lot of cost and effort saving. Shift left. If I waited for performance testing scripts to be written 2 months before go live, I wouldn't be able to shift left my testing scenario. And it's all about shift left. You would have seen that in the previous conversation that Ravi was running. He did have something around maintainability as well as shift left testing. This approach gave us that option. CI/CD is just a byproduct, I would say. We were easily able to integrate into the CI/CD pipelines as well. Any questions, anything? Yep.
I'll apologize before I start. I've got a bunch of questions. Thank you for the great talk.
No worries.
With performance testing, how do you start? Do you know the load beforehand, or do you start with this is the maximum we go for?
No. It depends. If it's an existing application and you're building a new portal, there is an existing portal. You already have data available from current production that you can plug in. So you would know that on the current website, you get around 100,000 hits per day. So that's your starting point. You could go with the assumption that I would be able to reuse that data. So analytics, production monitoring would give you some of that information. Otherwise, you start with something based on the industry standards. When a new website goes live, we think like the BAs and the business would have a vision of how many people they expect to use the website on a daily basis. So you start there, but then that doesn't give you all the information you need for performance testing, because performance testing is then you have to build scenarios as well. So building the workload for performance testing, you really need to have conversations with your architects, your BAs, to get an understanding of, all right, how many new members we expect on the website, how many returning members we expect on the website, and you design your scenarios based on that. So it's not a one-size-fits-all. You might have some stats available, but then you have to break it down further into what you need to build into the pipelines.
How does that fit into the CI/CD integration you talked about? Because you could have a scenario where today you have 10,000 per day, but there's an event coming up, say Amazon Prime Day, where you'd have 1 million a day.
Yeah, so this is where, when I was referring about different performance test scenarios, like you do a performance load scenario, you do a break test scenario, you do a soak test scenario, you run multiple different types of scenarios to cover those. So there is a scenario related to break testing of the application. So you slowly increase the load. For example, you start with an average load you expect on the website, you go to the peak load, then you go to 2 times peak load, and you continue doing that until the application breaks. That tells you how much your application can handle before you start seeing those 500 errors you would see on the website. So it's not one size fit all. Again, you have to test for multiple scenarios. And when it goes to building into CI/CD, it would depend on which environment you're testing in. So soak test and your peak load test scenario, you wouldn't run in your dev environments. Building in CI/CD, running on a daily basis comes into picture when you're making small changes onto your code and you want to see how much that small change is degrading the performance. You wouldn't run with a 100% load. You would probably run with a 10% load just for 10 minutes because that is more for comparison between how it was performing yesterday versus today.
Good. Like I said, I've got a bunch of questions. How do you decide costs? I'd assume it'll be expensive to say run 20,000 concurrent users on any APIs. If you're running it on all of them, definitely very expensive.
Yes, expensive as in the infrastructure cost or as in the resourcing cost?
I'd say primarily I'm talking about infrastructure side. Mm-hmm. Say I had a huge application, I'd wanted, say, performance tested. How do you decide on what kind of budget you need for something like that in terms of infrastructure?
That is where consultants come into picture. That is where we estimate. Based on experience, you would know if you want to test a 1 million into 10-minute scenario versus a 20,000 user scenario. You would know what sort of tooling you would need. For example, if it's mostly API based, I know I can use Gatling. Overhead would be much smaller, so I would be able to do that within 1 or 2 VMs. If I'm testing a thick client application, I wouldn't be able to hit that throughput with the same number of VMs, and I would probably need to go with the standard tools available in the market like LoadRunner. The cost would be different. So depending on the tooling, depending on the volume, your use case would differ. And 20,000 users isn't much anymore, as well as you do have load generators in cloud, which has reduced the cost a lot.
I might go. Just if there's anyone else, just before we get, I want to get everyone because we've only got. We'll go, but feel free to go up to Shweta after. Yeah. I'll just go right here. Yeah.
Cool. First of all, thanks for the talk. It's an awesome topic. I think a lot of companies and organizations are moving towards the shift left kind of mantra. A question I had is, how do you balance shifting left with the frequency of different types of tests? So like, how often do you soak test, because those are usually quite longer, in order to balance fast feedback but also not create a bottleneck for developers?
Yeah. Again, it's a balancing act. You always risk assess your application, your releases. For example, I do have quarterly releases, but I don't see in this quarterly release to the next one a huge impact or a shift in terms of my user base, as well as the volumes and the code base. So you always do risk assessment first. If you see it's a major release and you're going to change a lot in your code, which might degrade performance, you want to go through that cycle of a dedicated performance testing window. But if those are fortnightly small releases, you probably don't need to do that.
Yeah, cool. Thank you.
Probably got time for one more. But yep.
I was thinking, how would I talk for 45 minutes? That's a very long time.
Goes quick, doesn't it?
Thank you, Shweta. Just my question is, like you said that for sports days, they were having a lot of load on the website, for a sports website.
Yeah.
But for example, you have tested for 1 million before the day, and on the sport, you are getting 1.5 million for that day. And that website is failed that time because you have only tested for 1 million. Yeah. So in that duration, how do you handle, because that is critical days for them and it need to be fixed same day. So how do you handle that situation?
Performance issues aren't easy to fix. Once it starts breaking, it's broken, you would get your user bases down. But that comes down to your performance test planning as well. When you expect 1 million user load, you don't test with 1 million user load. You always test for future volumes.
Yeah.
You always test for peak scenarios. You also test for break testing. So because usually you would have monitoring in production as well,
Yeah.
you would know that now I have reached 200 times of the load that application can handle. Something is going to break. A lot of modern applications now try and have auto scaling built in place as well, which should be able to cover some of those scenarios for you.
So you mean to say that before the going live for the production,
Yeah.
you are testing that website for the 200 times more load?
Not before go live, like you would test it where it breaks. So
Okay.
you would know the break point. It could be 200%, it could be 20%, but when you're monitoring in production, you would know how much load has already gone into the prod, and you would have already started planning for it. Do I need to quickly add more servers onto the production nodes? Do I need to? You would already start mitigating that because you will have monitoring in production to give you some insights on warnings. You have reached 100% CPU, you're about to, like this application is going into trouble. You'll see all of that and you would have production monitoring team in picture.
Okay. Thank you.
Thank you.
Thank you for the response.
Thank you.
Thank you.
All right, with 1 minute till 12, we'll have a question now from Shweta for the audience. The gift card.
It's a fun question. So I did show the selfie that broke the internet. In which year that selfie was taken?
You got to pick it.
The lady over there.
You run it out, because I wasn't sure.
Yeah.
Thank you, Shweta. Amazing.
Thank you.
Very well done. Such a cool topic.